Children, very good morning to you all. I can see 41 students here. You all look silent. You all look silent. Yeah, better open up some mics so that you can respond to me. Yeah, Buddha. Please keep your mics, not to say silent, but under tight control so that when you need to respond, you can respond. Okay? Yeah. Yeah. So you can respond. Yeah. When I say good morning, even you are okay to say good morning. Yeah? Yeah, that's all.
Good morning, sir.
Good morning, sir. Very good, very good.
Good morning, sir.
Yeah, very good.
Good morning, sir.
Good morning to all of you. Yeah. Keep the mics open, but you can
morning,
put mics under. Yeah, very good morning, Buddha. Keep the mics under tight control, then it's fine. Yeah. So today's subject, it's for manufacturing. It's for manufacturing and mechatronics. Semester 2B1, thermodynamics. Yeah, thermodynamics. Okay. Yeah. This is a wonderful subject, eh? This is a very wonderful subject. And I think one of the best subjects you are learning. Yeah. One of the best subjects you are learning. And this knowledge, you should take something. It is more than the book knowledge. පොතේ දැනුමට එහා දැනුමක් ගන්න. So we are learning something based on this. You should gain something beyond the book knowledge. පොතේ දැනුම එච්චර වැඩක් නෑ පුතා. පොතේ දැනුම නිකන් මුළුවේ තියෙන it's a memory only and it won't help you. Okay? So this is a very wonderful subject, very practical subject, and very useful subject. And if you know this subject very well, your career will be very successful. You will be done. Okay? Thermodynamics is a very good subject. So you have to have a natural understanding of this subject. Yeah, and this subject is not about equations. Okay? It's not about equations, and it's about how the nature we are understanding. Right? It's about how the nature we are understanding. Okay, that is very important, very practical subject. You have to think about this. Okay, you have to think about this. Yeah. I have a text. I have the notes for you, but later I will email the notes after today's lecture. Okay, I will email the notes after today's lecture. And thermodynamics is nothing about the notes. Okay. Yeah. Let's see thermodynamics applications in the world. Okay. Let's see thermodynamics applications in the world. Okay. So can you imagine if there is any application, engineering and technology without thermodynamics? Okay. Keep your mics under control, Buddha. Thermodynamics applications in the world. Applications. Yeah. Thermodynamics applications. If you think of thermodynamics application, if you think of thermodynamics application, because we should be practical. So if you think of thermodynamics application, there are plenty of applications. Okay, there are plenty of applications. Yeah. So let me look into some of the applications. Okay. This is very important. We have to learn through the applications as well. Okay. Think of your kitchen. Okay. Think of your kitchen at home. Yeah. Just very simple. Think from your kitchen at home. Kitchen at home. Yes. What are the applications you see? Tell me what are not the applications of thermodynamics? Kitchen at home. Boiling water. Water. Okay, for drinking or to make a tea. It's a thermodynamics application. Thermodynamics and heat transfer application. Thermo means it's the heat, okay? Boiling water. Then cooking. I had some signal issues here. The cooking processes, okay? Again, related to thermodynamics. Of course, in your kitchen, if no boiling water, no cooking, it's no more a kitchen, okay? So these are the key things, okay? Boiling water, cooking. And if you have a refrigerator at home, okay, let's say mostly placed in the kitchen, it's okay to have or not to have. Refrigerator, body shoe. Refrigerator, again, it's a thermodynamic application, okay? What else? If you have an oven, okay, what is this? Again, it's a thermodynamic application, okay? Even making roti, thermodynamics application. Frying, Hildano again, yeah. Thermodynamics applications, okay? Sometimes you make breads at home, bread maker, okay? Bread maker, if you have bread maker, typing issue here, bread maker. Bread maker is a thermodynamic application, okay? Toaster. Toaster means you toast the bread, okay? Toaster. Thermodynamics application, okay?
So there's something wrong. We can't hear you properly.
Dilkuta, please switch off all the mics. And if you have a problem,
We can't hear you, sir.
Can you hear me now? Can you hear me now? දැන් ඇහෙනවද?
Sir, we can't hear you.
Excuse me.
දැන් ඇහෙනවද?
We can't hear you.
Hello, can you hear me now? Puta, can you hear me now? Yeah, please respond. Can you hear me now? දැන් ඇහෙනවද? Hello.
Hello, not properly, sir. Not clear. Your voice not clear.
Not clear. Oh, oh, oh. Give me a second. Give me a second. මට දෙන්න තප්පරයක්. Is it okay now? Can you hear me now?
Yes, sir.
Now okay? Okay. 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 Quite clear. If you have issues, please let me know. That is very important. If you have issues, please let me know.
We can't see anything.
You cannot see.
We can't see the screen, sir.
How about now? How about now? Can you see the screen?
Okay. Yes, sir.
Yes, sir,
Yes,
we
sir.
can see.
Okay, very good. Very good. Okay. Thermodynamics applications. Okay. Yeah. Thermodynamics applications. So we just talk about our day-to-day. Okay. Kitchen at your home. Boiling water, cooking, refrigerator, oven, making roti, frying pan, let's say bread making. Okay. Yeah. Here refrigeration. Okay, food refrigeration. Okay, oven is baking. So let's say instead of baking, instead of oven, I put baking. Toasting. Okay, toasting. Even sometimes you're ironing clothes. Let's say ironing clothes. You may put it here maybe. Ironing. Okay. What else? What else? Can there be any more? Of course, yes. Now, let's see. Thermodynamics. Yeah. Let's see. Can you hear me?
Yes.
Okay. Boiling water, you have to have a kettle. Okay. Kettle. This can be electric or can be just gas fired or electric. Huh? Gas fired or even maybe the wood. You can use firewood water, boiling water, so kettle. So cooking, okay, cooking. Let's say rice cooker. Rice cooker. And then you have the pans, okay, for cooking pots. Okay, and there can be many types. Refrigeration. You need a refrigerator. Okay, you need a refrigerator. Baking. You need an oven. Okay, you need an oven. Making roti. You need a roti maker. Roti maker. Frying. You need a fryer. Sometimes in McDonald's and all the industrial kitchens, they're using fryers, deep fryers, or frying pans. Frying pans. Okay, frying pans. Bread making. You need an oven or a bread maker. Okay, bread maker. Very interesting. Toasting. You need a toaster. Okay, you need a toaster. Ironing. You need an iron. Okay, now let's see, you as manufacturing and mechatronics students, okay, understanding thermodynamics for boiling water is understanding the phenomena of boiling water as well as your capability of design a kettle. Okay, your capability of design a kettle. You should know how to design a kettle. It is more than the shape. It is more than the shape. Okay, it has energy interactions. It has heat transfer interactions. It must have the quality boiling. Yeah. Little noises are there. Little noises. Yeah. So little noises are there. Yeah. So anytime you can unmute your mics. That is okay. Yeah, I want to control the noise. Even cooking. Yeah. Rice cooker. Pots. Sometimes you are using the warm water. Okay. Warm water for dishwashing. Okay. Yeah, dishwasher is there. Separate. Right? Even the dishwashing. Lot of things. Refrigerator. Baking. So you should understand the baking process. Of course, it is food, but it has thermodynamics aspect. Okay, it has thermodynamics aspect. Even making roti has the thermodynamics aspect. Even not only thermodynamics. So you have manual involvements. So even though you make it, even though in making roti, you have to put on the pan, then you change the sides and all. So there are thermal and some mechanical aspects of making a roti. Then frying. Okay, so when you fry, it is not only just putting oil and then let it heat or the boil and then you put your whatever needs to be cooked. Then you do the stirring as well. Stirring is mechanical. So those are thermomechanical and even can be automated solutions. Bread making. Okay, toasting, ironing. Okay, now I have a question. Are you ready to produce this? Yes, that should be your one of the objectives. Okay, මේව හදන්න ඉගෙන ගන්න ඕනේ. හරිද? See, kitchen appliances all related to thermodynamics. Yeah. So if you do not know thermodynamics well, how can you innovate this? How can you develop the products? You cannot. Okay, so there can be so many applications. Okay, so if I continue this, okay, if I continue this at home, some more would be let's see, iron. Okay, ironing clothes, you need iron. What else? Some houses in Colombo you can see air conditioners. Okay, air conditioners. Okay, sometimes you can see hair dryers. Okay, hair dryers. Hair dryers. Okay, hair dryers. Or let's say hair dryer. Now taking first after taking the bath. Sometimes people use hair dryers, the warm air generating from the hair dryer to dry hair. Yeah. What else? Some houses they use heaters in Norelia and all the up countries. For the cold days, heaters can be used. Heaters. Okay. Heaters. And some depends on the climates. Some are using humidifiers. Let's see, if some houses they have the valuable fires. If some have the valuable artifacts and all to keep these humidifiers, or some may have to remove the humidity, dehumidifier. Okay, dehumidifiers. Okay, those can be in the houses, but we don't have many because we don't produce. At least you are going to produce this. Air dryers, heaters, humidifiers. Even in your phone, you can see that the heat generation when you are using it, when there are digital, the electronics, there are processes taken place, your gadgets, electronic gadgets, phone, okay, your computer, and all need cooling. Even your computer, the microprocessors, there are cooling solutions. Even your LED bulb, CFL bulb, or even the normal standard bulb, we call the incandescent bulb. So those are bulbs. So the generation of heat somehow, you have to get it dissipated. Okay, in the bulb design, heat transfer, thermodynamics, notice the thermodynamics, but heat transfer consider very important, and heat transfer. Okay, heat transfer applications. Okay, should be both, because all this two, both of these two, thermodynamics and heat transfer applications, goes together. No heat transfer, no thermodynamics. Yeah. Bulbs, light bulbs. What else? So many things. Yeah. So many things are there. Okay. Even your electric wires and all. The thermal generation, the heat generation is there because of the resistance and all. So there should be a lot of things. Fans, electric fans. Yes. Fans. Okay. Fans has, of course, those are electrical items, but the resistance, that resistance generate heat, so the heat dissipation, the cooling of the fans, so those consider important, and those are thermodynamics and heat transfer aspect. Okay, what else? Yeah, anything? Any more thing? Of course, there are so many things. Let me duplicate this at home. Let's say even home design, home eco solutions, eco designs, okay, designs, eco designs, natural cooling, designing of glasses, windows, eh? or location of windows and all, natural cooling, then the energy efficient, energy, this keyboard issue today, energy efficient, energy efficient, eco solutions, okay, or solutions, solutions. So in this home designs, eco solutions, designing of the windows, the orientations of the house and all, okay. So this also needs thermodynamics and heat transfer, natural knowledge, okay. Now you can see how important, also other than this, even the nature, wind, modeling of wind, the weather, and all these things related to thermodynamics, okay, all related to thermodynamics, okay? Very important. See, if your knowledge, the natural knowledge is not there with you, do you think you will be smarter without the knowledge of thermodynamics? No, you will not be smarter. It won't say that knowing only thermodynamics you will make smarter, no such thing. But without it, it's a necessity to have this thermal scientific knowledge. The natural understanding is very essential for everyone, and this is very important for technology students. This is very important for technology students. So today we are discussing the importance. Yeah. So your knowledge, you are contributing for the home eco designs. You are developing some components, parts. Example, special window designs, louvers, louvers, and also your natural the cooling effects in houses, energy efficient solutions, everything you have to deal with. And let me continue this. Okay. On the road, on the road. Okay. On the road. Even you are running on the road, you will be consuming energy, your body will be warm up, and there are some kind of energy interactions. So any science, if it's closer to study this physical exercising or running, that science closer to this is thermodynamics and heat transfer. Okay, even simulating the blood flows and all, you need the thermodynamics, heat transfer, and of course fluid mechanics, and a lot of thermofluid things. Okay, running. How about the motorbike? Motorbike. Yeah. Everything. Okay, everything. including the engine power, engine cooling, even the safety of the petrol tank, the controls, acceleration, and all the controls of the movements mostly related to thermodynamics. Your car, if you have a car. Inside comfort, car air conditioning and the climate control inside. Then the vehicle running, the engine, the dynamics, the engine cooling, engine reliability, whatever related to automobile. Okay, automobile. It's related to thermodynamics. Without thermodynamics, you cannot develop this. Let's say Ferrari. Okay, Ferrari is a supercar. So they design this, they develop this not based on theory, but based on experience. That's why. If you can do the wonderful creations, it is something beyond the books. Sometimes book knowledge is not necessary, but your natural wisdom in understanding thermodynamics without equations, that is what matters. Okay, Ferrari, I just put here. Then the friction control, the friction generates heat, and when the friction generates heat, that can damage, that is one thing, and the other thing is it causes extra energy wastages and all. Friction controls. Okay, needs thermodynamics. Even the future hybrid batteries, thermodynamics aspects are very important. Thermodynamics and heat transfer aspects when it comes to the safety and all. Okay, hybrid batteries is a chemical, it's a chemistry based solution, but when it comes to the construction of the hybrid battery, it would be multidisciplinary, and thermodynamics would be it definitely be one of the key areas in the hybrid batteries. Batteries. Yes. So even fans and even the bathing. Yeah. When you take the bath, the water heaters and all. Yeah, bathing. The water heaters or geysers, we call bathing, also needs the thermodynamics and heat transfer solutions. Yeah. Okay, hybrid batteries. Yeah. On the road. Okay, everything. Yeah. Even emissions. You have the very toxic emissions. So emissions, not to say emissions, but control. This needs some careful controlled combustion and also using of the quality fuels and your piston cylinder ignition system and everything. So that's why it's related to environment as well. So emissions control in vehicles. Emissions. Emissions means there are a lot of things you have to learn, okay? Emissions, exhaust, huh? Yeah, exhaust control, emissions control in vehicles. Lot of things. The thermodynamics aspects are the fullest, okay? On the road, okay? So when it comes to energy, so let's say now, before talking about anything, let's say, so without understanding of thermodynamics, How can you contribute for this? Not possible. Okay? Not possible. Yeah, your understanding should be very important. That's why your understanding, not the understanding of the textbook, how to relate your knowledge to the applications, how to develop the solutions. Yeah, that is your goal. Okay, that is your goal of learning thermodynamics. Okay, thermodynamics. And you know that there are professions. There are professions. We have the heat transfer. Okay, heat transfer. There are engineers. 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 Computer issue today. Engineers. And there are technologists. Technologists. Okay. Do you know that they are very expensive and very rare? Yes, heat transfer engineers are there. Heat transfer technologists are there. So they can see what the others can't see. Okay. They can see what the others can't see. They can see through the nature. Okay. So they can understand the nature very well. And they are providing solutions in very innovative ways, and those solutions are really useful to the societies. So why not you can be a heat transfer technologist? Here are the professions, heat transfer engineers in the petroleum industries, even in the chemical industries, even in automobile industries, even in appliance industry, the kitchen appliances and all I mentioned there, and even in nuclear industry, even in nuclear power plants, even in coal power plants, you can see heat transfer engineers. But if those engineers working in coal power plants, if they are not heat transfer engineers, they cannot run the show. That's the issue. Let's say Noracholi, every time they break down. So they are the maintenance, the preventive maintenance, some design improvements are not there because those engineers are not sound in heat transfer and thermodynamics. So this is no joke. Okay. So you are learning probably the most important subject in your entire syllabus. Okay. So I'm happy to teach this very valuable subject, and we have to appreciate the subject first. Okay, that's what we are doing on the road. Okay. Now let's say in the air. In the air. Okay. In the air. Okay, or in the sky. Okay, sky. Aircraft turbines. Turbines. They call this power plants. Okay, they call power plants. Sorry, I have a little issue here. Power plants in aircrafts. Okay, power plants. It's thermodynamics, aircraft turbines, power plants, even design. Construction. Those should be very reliable. You know, this flying is not a job. Construction, testing, maintenance, all very serious jobs. You know, all very serious jobs. Aircraft turbines. Yeah. That is only one part. Okay. And in the aircrafts, there are air ventilation systems. Okay. Today I'm telling you, I'm showing you how important this thermodynamics and heat transfer knowledge. Okay. Later we will see in the internet the real ones. Air ventilation systems. Air ventilation systems, that is not only the aircraft air conditioning. Okay. Not only this, even heating the outer body of the aircraft. Okay. Heating the wings. Heating the wings and the body. Of the aircraft. Okay. Of the aircrafts. Yeah, so these are, because if no heating of the body of the aircraft, what happens? Do you know ice cream popsicle? You in the middle you got one wood stick and then surrounding ice. Same way, if the aircraft is not heated outside, because up in the sky temperature is over -60 and is below -60 Celsius. So once you come down, your aircraft will be something like a popsicle. Okay, like a popsicle, because -60 temperature, once you come down, all the moisture in there become ice and stick to the aircraft. Yeah. There are so many things. Air ventilation systems. Yeah. Oh. Yeah. Okay. No, no, no. So air ventilation systems in the sky. What else? Rockets. The propulsion solutions. Okay. Propulsion solutions. Propulsion solutions. Rockets. Rocket engines. Jet engines. Even the turbines, all propulsion solutions. Rockets. Rockets. Jets. Okay. Then the turbines, I put again here. Turbines. Sometimes you can see big propellers. It's like fans. propellers. Propellers. So later I'm going to share these things. Propulsion solutions. Let's see. For Sri Lanka and for the aircrafts in Sri Lanka. So even maintenance, testing, even designs, future designs for power generations or whatever. Who are going to do? Of course, you are going to do. Okay? You are going to do. So that's why this knowledge is something extremely valuable. Okay? Something extremely valuable, and you should get this knowledge, something even beyond the books. Beyond means you have to gain the book knowledge and you have to move more than the book knowledge, and you have to be practical. Some knowledges are not in the book, you know. Yeah, later I will share with you. Some thermodynamics knowledge are not in the books. Don't you believe this? Yeah. Let's say example. Okay. Let's say Japanese car. Versus against Chinese car. Okay, actually I'm not undermining any country, but let's say the situation. Chinese car. How can you comment on this? What can you comment on this? Japanese car, it's engines. Okay, let's say engines. Engines. Okay. Engines. You know that Japanese engines, the fuel saving wise is quite good. The technology in appearance similar, but in actual performance, you see a difference. Okay, so let me type that. Similar in appearance. Similar in appearance. Similar in appearance, but enormous difference. Okay, but enormous means it's a big difference. Okay, let's say big difference. There's a big difference. Why? Similar in appearance, but big difference. Means Japanese cars are better when it comes to engines and all, everything. The Japanese cars are better. What makes it? Uh, Similar in appearance, but big difference. Yeah. Tell me why. This knowledge of thermodynamics, that knowledge of thermodynamics is not in the books. In the books. And difficult to see and difficult to realize. Difficult to realize. Putala, understand? Can you understand? That knowledge of thermodynamics regarding the vehicles, what Japanese have, is not in the books and difficult to realize. And difficult to realize. Even the Chinese may be copying the Japanese, but it is impossible to copy everything. Okay? That's why. So if you need to be somebody, okay, somebody with a knowledgeable thermodynamics person, it is something you should understand beyond the books. And this knowledge may not be in the style you are seeing in the book. That knowledge may be your own. The way you experience, the way you see it, somehow it works. That's it. Okay? That's right. So starting today, you have to think the thermodynamic subject like this. Okay? It's not in the books and difficult to realize. But of course, there are thermodynamics theories. Those theories may be important, may not be important. But of course, you need this book knowledge, so I'm going to share this book knowledge as well. Okay, I'm going to share this book knowledge as well. But remember, you should see what underneath this book knowledge. මේ පොතේ ගන්න දැනුමට යටින් තියෙන සුබාදහමේ දැනුම. Okay, you have to gain that. It depends on your interest, your readiness. තමන්ගේ තියෙන සූදානම විෂය ගැන. විෂයට තියෙන උනන්දුව. How you closer to the nature, සුබාදහමට තියෙන සමීපතාවය. Because everything belongs to nature. You cannot do anything outside the nature. That is not possible. Even we are nature. And how are we ready to receive that undocumented knowledge again? අපේ සූදානම කොහොමද මේ පොතේ නැති දැනුම අපි ලබා ගන්න විශ්වයෙන් පරිසරයෙන්? What is our readiness? Those are very, very, very important. Unless you have that capacity, unless you are developing, if you are not developing that capacity, your book knowledge is something hard to work out. පොතේ දැනුමින් ලොකු දෙයක් කරන්න බෑ. තේරුණා නේද? Because the book knowledge, of course, important, but the knowledge you are receiving from the nature, that is more stronger. That is more stronger. That's why to do the innovations, to understand subject, the subjects of this nature, to have a natural, internalized තමන්ගේම දැනුමක් හැටියට ගන්න ස්වභාවික දැනුමක් වෙන්න. So you have to improve your wisdom in learning. Okay? Even to get ready to learn this, it's also kind of wisdom. Okay? That's why. That is very important. Your mind, your mindset, your mood of the mind. තමන්ගේ mood එක. ඒ කියන්නේ මේ විෂය ගත්තාම පුතා හරිම අద్භූතයි. හරිම අద్භූතයි. Yeah, it's really mystic knowledge you are getting. It's miraculous. හිතාගන්න බැහැ. කියන්නේ හරි පුදුමාකාරයි මේ subject එක. ඒ වගේ පුදුමාකාරයි. It's miraculous. It's wonderful knowledge. But you have to see that knowledge. You have to see that knowledge, and I am helping for that. But there are limitations because you have to see the knowledge. දැනුමක් දකින්නවා කියන එක කවදාවත් හිතලා තිබෙන්නේ නැහැ. How to see the knowledge? Once you see it, it's a gain. තේරුණානේ? දැනුම දැක්කට පස්සේ තමයි ඒක gain එකක් වෙන්නේ. දැනුම ගත්තා වෙන්නේ. So this is how it is. And I have to tell one thing, you are all now young adults. Okay? Young adults. Young adults means you are very you then above 18. අවුරුදු 18ට වැඩි අයට කරන්න බැරි මොනවද? නරක වැඩක් කෙරුවොත් you will be tried in the courts as any other adult. තමන් වැරද්දක් කෙරුවොත් සමාජයේ අනෙක් වැඩිහිටියන් හා සමානවම මේ වැරද්දට තමන් මේ උසාවියට පොලිසියට යටත් වෙනවා. Because you are responsible. So you are matching with the other adults now. කසාද බඳින්න පුළුවන් 18 පස්සේ. No issues. That's your preference. So because you have the responsibility. Yeah. Then you are free. Legally you are free. But you are independent. Yeah, above 18, you have no issue. But below 18, people cannot get you employed. I think below 16, but you are well above that. So if everything can, why not learning thermodynamics? Thermodynamics that's the point. You should see your capacity. This is the time you are going to learn by yourself. The knowledge that is unwritten. Pote neti දැනුම ගන්න. You are now qualified. You are now qualified. So that is my argument, and that is quite justifiable. Okay, that is quite justifiable. You are no more spoon feeding. Can be handing kiripoonawais නෙවෙයි දැන්. You are adults. So you are responsible. You should know what to learn, what to do, and what not to learn, and what not to do. Yeah. So you should improve your capacity. තමන්ගේ capacity එක develop කරගන්න ඕන ඉගෙන ගන්න. Learning capacity, your attitudes. It's your responsibility. Learning is your responsibility. So that's why you are here. Even teaching is our responsibility. Not to say teaching, but guiding you. That's what we are doing here. We are not here to teach you, but we are here to guide you only. Yeah. So it's totally up to you to learn. අපි ඉන්නේ මග පෙන්වන්න විතරයි ඉගෙන ගන්න එක දැනුම ගන්න එක තමන්ගේ වැඩ. So you should ready to receive the knowledge. Yeah. Knowledge is something you are receiving. දැනුම කියන එක තමන්ට ලැබෙන දෙයක්. දැනුම කියන එක ලබා ගන්න දෙයක්. ඒකට ඒ දැනුම ලබා ගන්න to get that knowledge, to receive that knowledge, there should be certain readiness within you. Readiness, ready window. So there is a saying. This saying is really true. It says that in Chinese saying, this one. When the student is ready, the teacher appears. That's what it says. So where is the teacher? Teacher is within you. Let me type that. When the student is ready, when the student is ready, is ready, the teacher appears. Okay. The teacher appears. So this is the fact. It's a fact. ලෝකේ ඉන්න අයින්ස්ටයින්ලා වගේ අය විතරක් නෙවෙයි. ලෝකේ ඉන්න ගොඩක් අයට. Even Sri Lankans. Even Sri Lankans. They have received the knowledge. Sometimes in unbelievable ways. Sometimes suddenly they receive the knowledge. Einstein and all. Even you are receiving the same. Yeah, that's the potential. Yeah. So it is not from the books. Me potli and the kalim me then the timbani ko hai. Yeah, you are learning Pythagoras theorem, but Pythagoras receives the knowledge. See, relativity, theory of relativity, Sapekshatavad. You are learning it maybe. You will be learning, but Einstein received it. Yeah, that's why. So, even Buddha, the Lord Buddha, yeah, right? Somehow, enlightenment means it's a kind of receiving the knowledge. It's a receiving the huge wisdom. The universe knows about the entire universe. Yeah, what's happening there, all the phenomena, everything, and about the everything. Or above also, it's a kind of knowledge. The readiness, you have to improve the readiness. So, paramita kila purani. Here, improve the readiness. So here you have no time to improve the readiness because you are already ready. Okay, you are already ready. You should know that. So now it's time to receive the knowledge for you. That's why you are here. You should know that. Okay? You should know that. That is extremely important. That is extremely important. Okay? Receiving the knowledge. And don't say, how to say, everything is important. Don't say even this tiny matter, the smaller things, sometimes may bring very big inventions, very big improvements, huge solutions. That's why. So everything from little to big, whatever, from small to bigger, from less serious to more serious, everything considered important. So your readiness for the subject, for the learning is extremely important. So this thermodynamic subject, your feeling about the subject, this will help you to learn the other subjects as well. Okay, you have to think of this. That is very, very, very important. That's why. So don't expect. Browse the web, internet එකට ගිහිල්ලා මොනවා හරි හොයලා copy and paste කරලා submitting a country CA coursework. Those are not up to your level. Okay, it's okay to read and then you internalize it. Then it's okay to put those with some reference. Right? तो निकम गिरावा के गीला कॉपी करला पेस्ट करला एवं मुकुट गन्ने तो तेरुं गन्ने तो विभाग की तरह पास वेला साथ ही कैप करेगा निकम ग्रुप बी को भी एलिट एंड नो ऐसे right? That is very important. So that's why your readiness is extremely important. This readiness is extremely important. Once you are ready, once you feel the magical nature, the mystic nature of the subject, you are done. Okay? You are done. Then thermodynamics is there and you have nothing to learn separately as thermodynamics. So this is very interesting subject. This is very, very interesting subject. So, let me save this PowerPoint as totally one. Listen. So I'm recording this so you can give the record also anytime. Okay. So now you are naturally receiving this. Okay. You are hearing. Once you feel understanding, even though it's not in your memory, you are done. You are receiving. Yeah. දැනුම කියන එක එහෙමයි. දැනුම කියන එක ඔක්කොම ඒ කියන්නේ දන්න දැනුම නෙවෙයි තමන් දන්නවා කියලා හිතාගෙන ඉන්න දැනුමට වැඩිය වැඩි දැනුමක් තමන් ළඟ තියෙනවා. Which means you have a knowledge. The knowledge within you is more than what you think that you have as the knowledge. Is more than the knowledge what you feel that you know. තමන් දන්නවා කියලා හිතන දැනුමට වැඩිය දැනුමක් තමන් ළඟ තියෙනවා. It's always like that. So don't worry. Whenever you are ready, you will receive the knowledge. That is that which means the teacher appears within you. That's all. So we are here to only to guide you. So now I'm going to show you some simple but important things how the other universities are doing. Example I'm showing you. Roti maker, roti hadariga, done by the National University of Singapore. Rotterdam. Oh, the Rotterdam. Yeah. I will share after that. See how even the simple thing is important. Automatically. Let's see. Please be with me. Please be patient. Be patient with that. Have a look on this. Till let me find something. Yeah, have a look on this. Okay, but this is something a very fine finished product. Very fine finished product. The new appliances. This is coming under new appliances. This is called Rotimatic. Hmm? Rotimatic. It's a kitchen appliance. Rotimatic. Yeah, this is very nice photos. Paste it. So this happened to be a finished product. So this involves thermodynamics and automation, and they make the roti. Interesting, eh? Interesting. So that's why nowadays, Meghat, do you think you need the book knowledge or you need the true natural knowledge? Subhadhami, Subhavika, දැනුම ගැන තීරුම් ගන්න එකද වැදගත් වෙන්නේ මේක හදන්න. Of course, you have to learn about the components and all, maybe the automations and all, but before that, this solution should be generated within your mind. The first thing is this, the idea, generation, the imagination, also in your mind. අදහස ඔළුවට එන්නේ. හිතන්නේ ඔළුවේ. Even initiative means it's kind of a power, power within you. So everything together made this developed. Totally other way. So do you think your book knowledge, only book knowledge can do this? No such thing. Okay? Yeah. Your creativity, your innovation, your natural knowledge of thermodynamics and natural understanding of automation, more important. Of course, here final design, you may get a designer support to do the plastic cover and all, but inside all the functioning components, electronics and all, those are technology. So technologists can develop this kind of things. So it's very important, creativity and innovation. Okay, creativity and innovation is extremely important. Creativity and innovation. So when you have this potential, and innovation, creativity and innovation. This is what involved. So for this one, you have to improve your potential. Okay, your potential for this. Creativity and innovation, let's see, potential. This is what the most important. The one has this potential, he generally and simply knows thermodynamics. Okay, creativity and innovation potential is very important. This is a very simple example, routine making. Yeah. So innovate this. That's why even in the world they do this kind of things. Yeah. Nowadays you can see a lot of other inventions as well. Yeah. Simple ones. Yeah. Example. Yeah, so why not you can develop your own one. That's right. So if you produce, it is good for Sri Lanka. Okay, it's good for you. You will be a millionaire even before you are leaving the university. Okay? Even before you are leaving. So this is another one. Bread making. See, bread making. So you put all the ingredients here, just on the switch. The bread is being formed. Yeah. See how interesting. So these are considered very good solutions for the society because people can customize the recipes for their health and well-being, and even though this may be they have to pay money for the bread making, but after that they have their own strength to make their own bread. Roti making save time, bread making save time, and also have a good quality bread. Why not? Okay, the things sometimes can do all. So you have to learn about the bread making techniques and the technology, the thermodynamics aspects, and all to make the quality bread. And later you are using the equipment to make that, making roti. It's very interesting. No big deals, you know. So what you need is the creativity and innovation potential. That's why I mentioned to you that everything is sacred. Everything is very serious. Okay? Don't neglect anything. Yeah. Don't neglect anything. Everything is important, even a simple matter. Because even in natural phenomena, you will see a very good applications. You will see very good applications. That's why you have to have that readiness. So bread makers, very important. Then, so this is all about the kitchen appliances, the innovations I'm putting. Very interesting. ඊපිරිත දුන්න නේද අමාත්‍යාංශයක් මොනවද මැටි වැඩ මැටි වැඩ වේවල් මැටි වැඩ. So I'm going to show you a මැටි වැඩ playwork. Yeah. Let's see. Playwork. මැටි වැඩ ගැන හරියට දන්නේ නැති අය කරන්නේ මැටි වැඩ තමයි. But if someone knows about මැටි වැඩ well, they will do wonderful things. This is a slow rice cooker. You know, these are very expensive. You know. Of course, the cooker is. So this is a mix of the traditional cooking. This is a blend of traditional cooking with modern technology. See? Creativity and innovation potential. Like you even there are clay makers. Even I have designed a clay pot. Later I will show you. I have designed a clay pot. I'm planning to do that now. Yes. Let me show you. Maybe here somewhere. I have designed one clay pot cooker designed for slow cooking using gas. So later I will share with you. Okay? A clay pot cooker design, because those are thermodynamics. Those are thermodynamics. That's all. So you can do wonders. So this knowledge of thermodynamics is not you are seeing in the textbooks. Do you think those creators, those new innovations, they know the thermodynamics? Of course they know, but not the book knowledge. That is more than book knowledge. Okay. Even high performance radiators, vehicles, let's say, custom made bike radiators. Sometimes for high performance bike, you may need, even you do development, maybe cooling of the bikes. You can see a lot of, I just mentioned because even you can try to develop with your own, how to say, even you can develop for your own bike for the better performance. Not to say extreme cooling is better, but yeah, sometimes cooling is important when it comes to the. These are the things of your interest, maybe. Yeah, I got this from the internet. See, anyway, this is creativity and innovation, all related to thermodynamics. Not only this, refrigerators. Yeah, it's your area. I mentioned that ovens and all everything, because in the market refrigerators all are imported. That is not for our climate. That is not for our taste. But those are being sold here. Some localized solutions. Refrigerator bicycle. Of course, you can develop this may be some designing maybe from the internet, but anyway, these are some practical aspects. Refrigerator bicycle. Yeah, you can see a lot, even the iron. The polka to silicon, we call this, I don't know, the charcoal iron, so whatever polka. But now we have electrical. Why not we can have a blend? Why not we can have a blend instead of electric? That's why we become the technology, not to say the inventors or innovators. We become the followers. That's why. So we are very weak, you know. We are very weak. So there are wonderful applications possible. Yeah, wonderful applications. A simple one. Eco solutions. Let's say example. I will put it here. Some designs. Let me show you an old design of an iron. Okay? Let me show you an old design of an iron. So if you can have a blended solution with new technologies, okay? So this is an old iron. Okay? Maybe you can learn some technology out of this. And that technology you can sometimes you can develop the boilers. Okay? This is an old iron. So that's why now it's time to blend old technologies with the new ones and make it something more eco-friendly. It's possible. It's possible. Okay? Not to say you are going to redo this, but you can make a blend of this old technology with some new one. Yeah. So then you use the alternative energies, not the electricity, maybe some. Again back to charcoal, but very nice, stylish. Right. Zero cost. Zero cost. Kolkata Kuchaladani cost but your iron is around 1000 watt iron instead of 1000 watt. Still in the big laundries, they are using these charcoal irons. You will be using charcoal irons. Okay. So all these things are thermodynamics. All these things are thermodynamics. And very interesting. So those are the household ones. If you think of the modern applications are in automobiles, in the aircrafts, even in the aerospace, even in any other industries, you can see a lot of applications. So you have to explore the applications. You have to explore the applications. Also the incinerators. Yeah, I'm just mentioning incinerators, boilers and all. You will surprise. You will surprise. Those are high energy consuming, but to have a solution with some sustainability, these are challenges. You can see the fire. So this is mainly thermodynamics and heat transfer, including combustion. And here you have the energy recovery and recycling as well. So let me show you another one. Regenerative. thermal oxidizers. Okay. Let me show you. This is for the environmental technology solution. This is a huge one. This is a regenerative thermal oxidizer. So this is for the environmental controls, the protections. So they are using in printing industries, some painting industries, refineries. You can see this kind of big solutions. So all are thermodynamics. All are thermodynamics. Those are the industrial applications. Thermodynamics. So you can see how wonderful, how valuable this is. Even power generation. Don't think power generation is electrical. No such thing. Power generation is, let's see, the thermal power generation, thermal power plant. You can see huge thermal power plants. Thermal power plant, only electrical part is only the generator. That's all. Other things, all thermodynamics. That's why even for the mechatronics students, the knowledge about thermodynamics is extremely important. You can see you are going to apply automation where on this kind of applications. These are thermal power plants. Yeah. So you can see the huge system of processes. So you can see all. So without having a good sense of thermodynamics, you cannot contribute to that. And other part, if you truly know thermodynamics, that is beyond the books, you will be done. Okay? You will be done. So those are the applications. So why not? We have to develop. We have to develop our own what? Solutions. We have to start our own solutions. For the society. Okay, our own solutions for the society. Society. So this is our target. Okay. Because if you are developing your own solution for the society, means for your solutions there is a demand. When there is a demand means there is a market. And when there is a market, you are more than surviving. Okay, you can create the jobs for the others, you can run the industries, you can run the enterprises, you can run the businesses and all. It's very nice. Yeah. Also, let me share with you the other areas in thermodynamics. If you think of food, food is very important nowadays, you know, food and agriculture. Okay, agriculture, you know that cold chain, cold chain, cold chain means the cooling solutions, refrigeration solutions, starting from the raw material until the customer bring the goods to home. That is what we call cold chain. Or refrigerate applications. Okay, refrigeration applications. Cold chains. Cold chains. So in fisheries, in dairy industries, you can see in agriculture, cold chain is extremely important. Cold chain. So the cold chain contains let's say cold storages, cold rooms. Okay, cold rooms. Yeah, cold rooms. This is a very small one. Okay, there are huge cold room solutions. Yeah. And also, there should be refrigerated trucks or cold trucks. Cold chain trucks, cold trucks. So time will come for us to produce all these things, cold trucks. So now we are importing, very sad to say, still we are importing. Why not we can produce this? This doesn't need much technology. Yeah, cold trucks. So now we are in the process of developing the solutions for our own use rather than importing. Also in supermarkets, okay, the display coolers and all in the supermarkets, you can see in the supermarkets the display coolers and all. Refrigeration. So refrigeration is one of the very important areas. Okay? Same air conditioning. Also thermodynamics application. Power plants, thermodynamics application. So Balashakti Amatyasya, now there are power solutions. So finally, solar thermal applications or whatever, using the natural energy, so thermodynamics knowledge is very important. Yeah. So that's why. Yeah. So you can see in Sri Lanka, one of the, how to say, one of the, how to say that? One of the reasons to make technology that not popular. Let's see, one of the reasons that we need to import lot of things. Okay, ගොඩක් දේවල් පිටරටින් හේතු වෙලා තියෙන්නේ මොකද හේතුව mainly lack of knowledge, the true knowledge in thermodynamics. That's the issue. Lack of true knowledge in thermodynamics. That's the issue. Every industry use boilers. Many industries, they are using boilers and daily. And Sri Lanka importing thousands of boilers yearly. Why can't we produce? Why, if they can produce, why can't we produce? Boilers. Yeah. So you can start from smaller scale boiler. How to construct a boiler? That's why. So you need something more than good knowledge. Your creativity. That's why you should be ready for this. To make a boiler, you have to generate steam. You can develop one for industries. You need to have the same way, but you can develop in another way and have the same performance. Even the burners, combustion. Burners very important, but we are importing burners as well. We are importing burners as well. Industrial burners. That's why when we are importing all, what happens is even the industrialist, they are reluctant to start anything because they have to buy everything starting from the nut and bolt to the major components to big systems. All we need to import. So that's the issue really. So there's a burners. There should be burner developers in Sri Lanka, and you will be the one with your future knowledge of heat transfer thermodynamics and combustion. Okay, you will be developing burners for our Sri Lankan applications. Even this time I gave one student group a final year project to develop a burner. Yeah, to develop a burner. It's very important. Burners. It is very important. So these should be your interests. These should be your interests. And the other thing is, so can you remember earlier days and even now maybe in the PIM හදන්න but now no. From there you can learn the basic phenomena. What's the reason for this? But we need burners as well, all related to thermodynamics. Now, with all the elaborations, you are seeing the opportunities. Okay? So, what you are seeing are the opportunities. You are seeing the opportunities, not the issues, but the opportunities. Yeah. You are seeing the opportunities. Okay? You are seeing the opportunities. And remember, knowledge brings the opportunities, not to say the book knowledge. Eh? Knowledge brings the opportunities. Knowledge brings the opportunities. Knowledge brings the opportunities. Knowledge brings the opportunity. The true knowledge, okay? Not just the bringing, not just the book knowledge. Book knowledge is usage is very limited, but it helps to explore the knowledge as well. So I'm sharing the book knowledge and all the knowledges you needed to make you somebody. Okay, to make you somebody, so you have to learn this. Okay. So it's 10:30, so I prefer to go for 1 more hour after taking a break. So shall we meet at 10:45? Kutala, okay? Are you okay? Respond to me. Eh? 10 minutes break. Okay.
Okay, sir.
Okay. So we will meet at 10:40. Now my time is 10:29, so 10:40 we will meet. Right? Okay. Good. All of you are here. Yeah, children. I can see all are here. 55 now, but early 56. Can you hear me? Yeah, I just want to make sure that no issues in hearing the lecture. Another?
Yes, sir.
Okay, very good. Any chance for you to open your mailbox? Manufacturing and mechatronics. There I have sent you the notes. Okay, a complete note. A complete note. And we will be learning until the chapter 5 of this note. Okay, chapter 5 of this note. The other part may be in applied thermodynamics. So for the thermodynamics, this year lecture you are learning until chapter 5 of the notes. Okay, until chapter 5. Did you receive the notes? Thermodynamics 2020 is 2B1. Pneumatic.pdf. That's a file. So you have the file. You have the file. You have the notes. Ambuna, you know the note. Okay, got it?
Yes, sir, we got it.
Okay, got it. Just open the file if possible. Yeah. So for our own solutions for the societies, of course, opportunities. Knowledge brings opportunities, and you got the notes. Do you think notes can make that huge impact? Not at all, but it helps. That's all. So we are learning this is the approach. Step by step. Okay. Step by step. That is very important. This is the learning approach. Okay, this is the approach. This is the approach. Step by step. Simple. Okay. Step by step. Starting simple. Okay. Starting simple. Then you can go to complex. That's the approach. And one more is here in our approach. starting from known, then to unknowns. When you are learning in this way, when you are learning in this way, learning in this way, the keyboard has some issues. Sorry about this. Somehow I have to manage this. When we are learning in this way, what is this? You see this? Yeah. You may notice that. It is always one step at a time, okay? And it is simple and known to unknown. So it is always simple, okay? This is the approach. Also always known. Because known to unknown means it's always known. And step by step means it is easy. Okay? Easy. Easy going. Oh, it's easy. Okay? Not difficult. Not difficult. So this is the approach. So always simple. Simple. Always simple. Always known. And it is easy means step at a time. Step at a time. So this is the approach. Okay. So this should be your approach as well in learning, because this is for you. A step at a time. Easy means that one. step at a time. Easy means. Yeah. A step at a time. Okay. So this is our approach. Okay, a step at a time. So I will try to guide you in this way. Okay. You also try to explore the knowledge by yourself also in this way. And if your knowledge seems very complicated, if the knowledge you feel seems very complicated, means that knowledge is not clear to you. Okay? So clarity is not there if you feel it is complicated. So simple to complex means always simple. Simple means clear. Okay? It should be a very clear knowledge for you. Once it is clear, you know that you know. Okay? That's why always know. And it's easy means, of course, anything if you understand it, it makes you really comfortable in that knowledge. Yeah. Simple. Simple means it's always clear. Then it is always known. And it is easy and it is about only the interest and no any difficulty. Okay? So interest driven. So this should be your approach. So even in thermodynamics, of course, the subject you are learning, if you feel it is complicated, it is not known. Yeah. And if you don't see the flow of the subject, step by step means there is a very good subject flow of the subject. It's a good flow. Okay. And if the flow is not there, then you have to look into that. And you have to get it cleared by yourself to organize the knowledge, link the knowledge in step by step, and make it clearer to you means you make it knowledge simple. And once you organize, make it clear to you, it is known to you. So that's how this thermodynamics you should learn. Okay? That's how the thermodynamics you should learn. Okay? I hope you understand this. Now you have the notes. So I mentioned you that we are covering only until the subject, the chapter 5. Chapter 5. And do you know that those days when people invent the things, automobiles, refrigerators, air conditioners, even light bulbs, this knowledge was not there, but they have realized the solutions. Okay? They have realized the solutions. And that is very important, even for you. This knowledge until chapter 5 is enough for you to do something big. Okay? And if you feel that knowledge is good, you can still proceed the rest. That is okay. You can learn about the heat transfer, no issues. Understand? Yeah, that is very important. This way. So if you open up the notes now, let me also open up the notes for you now. Okay. This is your complete note. You have to go through this, the chapter 1. You have to go through this chapter 1. Those are in the syllabus as well. Then you have to understand chapter 1, 13 pages. Then you have to go to chapter 2, okay? And you have to learn chapter 3. Chapter 3, there are 3.1, 3.2, and so on. 4 sections. In chapter 2, there are, including the tutorials, 8 sections you see. Chapter 3 is 4 sections, including tutorial about the steady flow energy equations. Chapter 4 is quite practical again, that's about the second law of thermodynamics. And chapter 5 is about the vapor power cycles. Okay. And 572, you can see page 56, you learn something about refrigeration as well. Okay. And we will see, if we have time, we will continue this, but somehow in applied thermodynamics, you will explore more. Okay. You will explore more. So what you need to do is, I'm not 100% going to read this for you in the class. So you go through this in general, you go through it. Try to understand this. Okay? Try to give some practical meanings to this. Each and every sentence. Okay? Try to give some practical meaning. Try to understand this. So if you do some careful, very thoughtful receiving of knowledge through this, it will be step by step. Still, it will be simple to complex. That is, of course, nothing complex, because step by step, starting from simple, always simple. Okay? And it is always easy. And you are learning from known things. You can explore the knowledge, so there won't be any unknowns for you. Okay? There will not be any unknowns. People understand? Yeah. Good. Good. So there will not be any unknowns for you. So today is starting. Yeah. So I'm going to share some little important things. Those are not in the books. Yeah. In Asia, of course, in Japan, China, they are learning these things, but we are not learning these things. So that's why. So I'm thinking of sharing this one. Probably important for you. Have you heard? Yeah. Okay. The 4 elements. 4 elements we call. 4 elements. 4 elements. Before you are 4. Okay. 4 elements. Four elements. Okay, 4 elements. So, what are the 4 elements? Even it's okay to note down this. We call the first element, we call, let's say there may not be that order, but First element we called earth element. Earth. Okay. Second one, let's say wind. Third element we call water. Sorry, let's say heat. Okay, heat. I changed the fourth element here to wind. Earth. So here I put water. Earth, water, heat, and wind. In Sinhala, we call this earth means, in Sinhalese or even in the Indian language, maybe Patavi. Apo, Tejo, Vayu. Okay, 4 elements. So I'm not teaching you any religion, but 4 elements is common in the philosophies. Earth, what is earth means? You know the earth. It is something we call it's something like a quality, and that quality we call solidity, the solid nature. Okay. Ghana swabhave, solid nature. इसको लिखूंगे ना the properties of matter. Isalam, how you clarify the matters? Solid, Ghana, liquid, drava, air. Why? That is the European clarification. It won't help you. Okay. So earth is the solid. What is water? The solidity is earth, means solidity. It's a quality. Okay. Solidity is a quality. Okay. It's a quality. That quality we call earth. Okay. A quality. A quality that we observe, we feel. Okay. A quality. What is water means? What is water means? Another quality. What is this quality? Flow. Okay. Not move, but the flow. Flowability. Flowability. නිකන් ගලන්න පුළුවන් ගලාගෙන යනවා in Sinhala we call flowability. River, water flows. In the wind, air, we won't say flow, but it's a flow, but we call it wind blow, but also a flow. Okay. Then for the combustion, from the petrol tank to the engine, the petrol flow.
Excuse me, sir.
Yeah, Buddha.
Is there same slide?
Yeah, same slide. Oh, sorry. Thank you for reminding. Oh my God. Yeah. 4 elements. Yeah, thank you. You have to raise your voice whenever you feel a concern because even sometimes this can be missing. Yeah, so this is the four elements. Earth, water, heat, wind. So thank you for reminding. Yeah. So what is the flow ability? It's a quality. Even when we drink water, it flows. Okay. Solid you cannot drink. Yeah. So when you heat up the metal, it becomes liquid. It can flow. Okay. So flow ability is a quality of matter. Okay. Yeah. This is very important lesson I am sharing with you. This is for you to receive the knowledge of thermodynamics naturally. Yeah. Then the heat. Before heat, let me explain you. The wind. The wind. Wind means inside our body we feel the wind. Wind means we call expansion. Okay? Expansion. Okay? Expansion. Just the simple word is pimbino කියලා කියන්නේ expansion. And contraction. Aquilino. Okay? Contraction. Contraction. Again a quality. Expansion, contraction. Again a quality. Okay? Again a quality. So earth, solidity. Okay? I'm going to prove this. Flow ability is we call the water. Yeah, we just call water, just not for the drinking water, but the anything that flows. Heat means we call the hot and cold. Okay, that is the heat. So that is the energy component. That is the energy. So hot and cold is again a quality. That's the energy component. Okay, that is the energy component. Very interesting. I'm going to discuss this. Okay, very simple. Okay, let's say air. Okay, air. So air in the wind, it blows because of some, we call it the pressure differences. High pressure means somewhere it contracts. Okay, low pressure means somewhere, yeah, high pressure means anyway, you can see the expansion and contraction in the wind even in nature. Okay, even for in the breathing, when you breathe in, the lungs expands. When you breathe out, lungs contract. So what happens is when the lungs expands, air goes in. That is the normal way. when the lungs contracts, lungs can be inhaled, air goes out. We call it breathe out. So the breathe in and breathe out because of the lungs expansion and contraction. We call it the wind quality. Okay. So I will take one by one. I will take one by one. So starting wind. Example, lungs, inhale. Okay. Another example, in an engine, motorbike engine or whatever, you see, in an engine, you have the suction strokes, compression, and so on. So there you see in engines, wind expands, okay? Yeah, it produces power, okay? What expands? When the combusted liquid fuel mixture once combusted, because of the pressure, somehow whatever, it moves, okay, expands. Lungs, engines, even wind in weather, nature, wind expands. Even heartbeat and pulse oil, because of that, somehow the expansion and contraction. Yeah. So even the pumping tire with air, okay, air pumping to tire, okay, tire, air pumping to tire. Pumping to tire, into tire, tire. This is a very important example. Air pumping into tire, okay. TYR, I think spelling should be okay. So what happens is, when air pumps to the tire, somehow you can see it's related to expansion and contraction. So let's say after this tire becomes, yeah, later I will discuss that one, and so on. There can be lot of example, even the cooking, and even the cooking, water boiling, you see inside, once energized, you can see some expansions, the noise, and even escaping molecules or escaping water as steam. So there you will see this expansion and contraction, okay, expansion and contraction. Even within hot and cold, you see expansion and contraction. So this is up to you to think. Now, let me look into not the wind, but now I will look into water. Now I will look into water. Flowability. Okay. Very interesting. Water. Water in the river. Okay. water in the river, it flows. Okay, flowability, the water quality, the water in the river, it is the water in four elements. Okay, then the wind flow. Okay, wind flow, blowing of wind. Wind. Okay, it's a flow again. Okay, air flow from a fan. Okay, see, interesting. Air blow from a fan. Fan. Okay, then let's say spray gun. Okay, spray gun, paint or water, whatever, spray gun. See, mechanical devices, spray gun, water in the river, blowing of the wind, air blew from a fan, spray gun, water in a pipe. Okay, pipe water. Okay, pipe water. Very interesting. Afterward, you will see some surprising things. After we discussing solids. Okay, very interesting. Okay, water. So you can have a lot of examples. Okay, solid. So I'm going to discuss solid now. Solidity. Solidity. See whether you agree with this or not. Water in a glass. Yeah, children, speak up. Is this solid? Because water in a glass is not flowing. Okay, so let me explain you. If you put water in a glass and if you can smash on the water in the glass, if you smash on the water in the glass breaks. Why glass breaks? Because water has some solidity and it can transfer the force to the glass. Okay, water in a glass is something like it has a solidity. If you smash, you can water dala vidruga water dala water uding. If somehow if you can hit the water, glass can break. Even sometimes water is used to cut metals. Metal can yakada kapanda water pavichi karna. Why? Water can make as a very sharp and solid matter. Okay, that's why. So this is a different knowledge you are receiving. Okay. Air in a trash tire. Okay. Pressurized air in a tire. Okay. See. Pressurized air in a tire. in a tire? Hari. Okay, I'm asking in Sinhala. Tire ke hulan tibba kiyala tire එක මිරිකන්න පුළුවන්ද? No. Even on these 4 tire, tons are being transported in vehicles. 4 tires in vehicle. Tons of goods are being transported. Why? Because air in a tire looks solid. It is not flowing, but air in the space, it flows. Water in the river, it flows, but water in a glass, it will not. But of course, when you drink water in the glass, it is something like it's flowing. Okay? Not drinking. This is smashing water in the glass. This is water in the glass anyway. It is not solid because it is not water anymore, because if water, it should flow. Water in a glass will not flow, so it has a solidity. Air in a tire, it's always there, it won't flow. But when it go on a hump, when it goes on the humps, the tire air in the tire has certain expansion contraction. Tire shape it absorb it. Expansion contraction. It means air in a tire, it is not totally solid, but it has a bit air quality as well. Okay, and that's how you are balancing the qualities. You can make air solid 80%, you can have 20% the air with air quality, means with flowability or expansion and contraction, not to say flowability, expansion and contraction. So air in the tire has the earth quality. Most of the quality of the air in the tire is earth, solid. Okay. Then the air in a balloon, not that solid, because you can squeeze a little bit solid. You can see for a kid, the kid can hold it. Somehow it has some expansion, contraction. Maybe this one is 10% earth, not only 10% earth. I just put here 90% expansion, contraction, wind. See, this is very interesting. That's why to learn thermodynamics is something you have to do with nature. Air in a tire is the other way, 90% earth. Earth properties there. 10% expansion, contraction. Okay. Water in glass, no flow at all. Okay. No flow at all. So I would say 100% earth, unless you are tilting it to let it flow. Okay, 100% earth. Okay. Water in a glass, let's say 100%. Then metal rod. Okay, metal rod. Let's say 98%. 98% earth solid. Okay. How about the other 2%? Other 2%? Let's say even when this metal get higher temperatures, it expands. Metal get lower temperatures, it contracts. So let's say 95% earth. 95% earth. 5% wind. Okay, 5% wind. Very interesting. Metal. So the metal boiling after the hot metal, the liquid, then so when the metal becomes heated and becomes liquid, so it depends on the application. It has the flow ability and it has certain solidity and it has some high temperature. That is what we call heat. Okay. Now you can understand how you see the solidity. Solidity doesn't mean you have to have real solid like wood or like metal. Even you can use glass, you can use liquid water as a solid. That's why in braking systems, to move the brakes, you are using brake oil. Oil can flow under high pressure. It is like moving a solid in a flexible way. Solidity is there, flow ability is there. To understand? So I'm not sharing this lesson anymore. So you have to learn this because this is how you should think when it comes to thermodynamics. You are balancing these four elements.
Excuse me, sir.
Sorry, Buddha?
How we categorize water in blowing of wine?
How you categorize?
Water in
Yes, in blowing.
Yes.
Blowing. Blowing means wind. Okay. So let's say, yeah. So this is your question. Is that so? Is this a question you're asking, or is it, you need an explanation of what I mentioned?
Question.
Eh? Question. Okay.
Mention blowing of wine.
Wind. Wind, Buddha. Wind.
Wind.
Wind කියන්නේ හුළඟ කියන එක. Yeah. Okay. Wind. So wind means it's a flow. Okay. Let's say water in a river. Water in a river, it flows. So it looks at the higher quality of wind. Okay. We can hulang කියන එක නෙවෙයි මෙතන. Okay. In four element, wind, the definition of wind is the flow ability. See, what's the definition of wind? Sorry, expansion and contraction. Wind. Definition of wind is expansion and contraction. So in water, here 10% is the flow ability. So this is, we have two W's. We have two W's. We have two W's. Okay. So air in tire, 90% earth, 10% wind, WI. I put WI. Yeah. Air in balloon, maybe 10% earth, 90% wind, expansion, contraction. Okay. Yeah. Metal rod, it also has 95% earth, 10% wind. Okay. So when it comes to water, even water, boiling water, let's say boiling water has the wind quality. So boiling water has the expansion quality when the water get energized. Further energized becomes steam. Okay. Yeah. Steam. Yeah. So we can see that is kind of expansion. separation, the gap between the molecules becomes more and more. So it has certain expansion. But you can keep it compressed, means contraction. Example, in a boiler, so you are getting the high pressure steam. So there you can see the wind quality of water. In the boiler you are seeing, of course, certain solidity is there as well. Okay, certain solidity, because the steam can run the engines. To run the engine, so steam must have a certain solidity to move the pistons. Okay, so even the water flow, sometimes we have the water turbines. So in the water turbines, because of the flow, the solidity there makes the turbine turns. That's why the flow and solidity. In the flowing water you can see. That's why the turbines can turn from the water, flowing water. You got the answer? Yeah. You understand? Okay. So that is about the earth. Then let me go to the other one, the heat, the last. So when it comes to heat, when it comes to heat, when it comes to heat, let's say when it comes to heat, of course, boiling, example, boiling makes it hot. Okay, boiling. So let's say in a boiler, yeah. So you make it hot, as well as the water becomes water, the solid quality increase because of the pressure. Pressure means it's a kind of solidity. But releasing pressure means it's a kind of expansion. That is wind. When it expands, there is a movement as well. That movement we call the water. Okay, boiling water. Okay. And also refrigeration or cooling. So heating. Heating. So heating and cooling. Sometimes can be natural, sometimes can be man-made, sometimes can be industrial processes. Okay, so makes it hot and cold. So the issue is when hot and cold interaction is there, the earth quality, the water quality, the wind quality can be changed. Example, when you are heating a metal, it can expand. Yeah. Or when you're cooling it, it can contract to come back to the normal length. Yeah. So when you boil water, you can see the sound and all. Somehow you can see even the water bubbles and all. A kind of expansion is there. Expansion doesn't mean the water volume increase here. Okay, there is no increase in water volumes. Let's see, but because of this kinetics, there can be some expansion like thing. That's why the steams are being evaporated. Okay. Yeah, anyway, the density change, the expansion is there with the changing of the temperatures. Yeah. So hot and cold also related to the temperature. Okay, boiling, cooling, heating, any substances. But when it comes to some other, like the wood, examples, when you heat a wood, it may not expand, it may not contract. Yeah. If no oxygen, when you heat it, it may not burn, but it can be decomposed. Yeah, somehow. Huh? Yeah. So it is how you are energizing. Make it hot and cold. That is the molecular, the vibrations related to hot and cold. So this is related to hot and cold quality, and this is related to temperature. That's a part, okay? This is related to temperature as well. Very interesting. So for this lesson, all the knowledge you are receiving based on your life experiences, okay? Not from the book knowledge. Okay, so these 4 elements. So think about this, and this is very important in the designs. So balancing the quality of these 4 elements is part of the creativity, innovation, and the design. Balancing of the 4 elements in the designs. That is very important. Even in a tire design, you have to think of this 4, how the interactions and all. And that is what we call the technology somehow. Later we develop equations or whatever, but basically all have to do with these 4 elements. That's all. Okay. Example, even sharpening a knife. Sharpening a knife to cut the things and all, again, it's about the intensity of the earthness, the solidity, the intensity there. The flat and the sharpen, the difference. Yeah, see, that's how we are improving the intensity of the earthness sometimes. Even the water, high pressure water you can use as a tool to cut the metals even. So the solidity increase. Sharpness means the further intensifying of the solidity. Yeah. Can break the solids. The increasing solidity by sharpening can break the solid, can cut the solids. That is very important. Okay. So let's say this way, when you think, even the sudden changing of these qualities, let's say even the recently the Lebanon, the blast there, so you can see how the pressure waves, the propagate, expansion, those are in milliseconds. The wind quality finally becomes intensified, and it is more than the flowability. Because of the heat, the triggering, the sudden heat, the wind effect becomes very prominent, and then you see the mushroom cloud, and I think a 10-kilometer radius propagation of the shock waves in milliseconds. You have noticed it. That's how the heat effects to change the properties, heat effect. So sudden increase of heat. It's a detonation. It's a burst. Yeah, it's a burst. So even in the engines, the same thing. The sudden ignition, anyway, it takes a little time, controlled one. So you can see the certain solidity they are trying to expand. When trying to expand, against the expansion, this solidity makes it expand. Means overcome the reaction. Resistant from the air. Again, if I explain, in order for the solidified, that solidity of that violent combustion happened in the Lebanon, Beirut. So in order to release that, the wind effect or the shock propagation happens. Okay? It is something like this. So four elements, even in the sea undercurrents, you will see this. Even in thermodynamics, natural systems, the sea undercurrents related to thermodynamics, and even the wind blowing related to thermodynamics. So you see these four elements. Those are playing a huge role. Yeah. Same way, maybe in the human bodies also, you can notice the four elements. That is very important. So keep in mind, today's lesson is very, very important. It's 11:52. We have to stop the class now, but before that, I have to put one more keyword here for this. Space. Okay. Space. Space. So later I will talk about space. This is very important thing. Four elements and space. Okay. So four elements are there and the space. I have to discuss this separately. And when it comes to the us, we have another separate addition when it comes to people. Okay. So we call this consciousness. 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 Yeah. These are not the words. These are very, very real. Very real, meaningful ones goes beyond the words or space. Space for elements, consciousness. So this consciousness is only relevant to the humans. Okay, humans. So that is the extra thing the humans have. Even the intelligence is, even the nature has the intelligence, even the trees. They respond to the nature and all, but when it comes to the consciousness, this is especially for humans. Yeah. So there can be natural intelligence. අපිකට ඉව කියලා කියනවා, ඉව කියන එක ඇවිල්ලා intelligence. Intelligence. Now we have artificial intelligence and all. So intelligence. So you can use intelligence. We can use intelligence. I have the keyboard typing issues here. Intelligence. Okay. Good. So those are the things. But here, we are talking about this. Using our intelligence and consciousness. Okay. So that's also you have to aware of everything, you know. Somehow we are on this earth, so we have purposes. So when we are learning, we have to learn the things very naturally. So that is now we have the artificial intelligence. Anyway, those all learn from our own intelligence and from the consciousness. But no one talks about artificial consciousness. That is not possible. We are talking about artificial intelligence only. Yeah. But nature has a consciousness. That's why even the corona came. Nature has a very strong consciousness. Some they call it different words, but consciousness is there for the nature. So that's all, Putala, for today. So next lecture, I will talk about the space and I will look into the notes. So notes are up to you to read. I'm not going to discuss the notes here because I told you that you are now adults. You are 18 years plus all. So if you are eligible for everything, why not learning yourself? So that is my point. So be strong in learning. So we will guide you. That's all. So bottom line of this module, after learning, you should be able to look for your own solutions for this. Slide 1, slide 2, slide 3, slide 4, slide 5, slide 6. See, unnoticed knowledge. So you are looking for those things. Now, slide 7, those are the cream of the knowledge today, the lessons today. Now, so innovations, we talk about this. And then the modernizing the things and the importance of thermodynamics and the learning approach. And after that, see, I have started from known. This is what you really know, you know. You know the solidity, you know the flowability, you know hot and cold, you know expansion and contraction. And do you know that the real understanding of or real feeling of expansion is not just this word, you know. It is real. When you feel your breath, you feel, oh, expansion is real. When you look into the vehicle, the piston cylinder movement, you know expansion is real, contraction is real. So, as I mentioned to you, this knowledge sharing, we have started from known things. Okay? Real known things, truly known things. Truly known things. And if you have issues here, you better get clarified yourself. Okay? And this nature has this. You imagine this nature has these four elements, this nature. Everywhere you see these four elements. Hidden in the trees, hidden in the earth, hidden in the water, hidden even in your kettle. Yeah, you see this even within you. You see these four element properties, four element qualities, not to say properties, qualities. The quality means, let's say, Lunu Raha. The taste of salt. Can anyone define the taste of salt? No. But you can experience it. Taste of salt. Now you cannot define what is the taste of salt. But taste of salt, it's in the wordings. You cannot define it. You have to feel it. You have to experience it. Same way, the solidity. Yeah, you have to experience it. You have to see it from where you are going to see these things. You know, you have to see from your brain. Okay, even the lunura, you finally you taste it, but anyway, this reflects from your brain and mind. That is important. So the thermodynamics, the basics, the four qualities, and the including space 5, You are seeing all these from your brain. Yeah, that's why. So this is more, even though it is physical, the experiencing is totally depends on you. Okay, so you are learning how to learn thermodynamics, and you will learn thermodynamics, and on top of this you will give some very good meanings to the thermodynamics text I have emailed to you. So this is a wonderful subject. This is very real. This is very real, and you are you should spend some time on this. You should feel the subject very well. You have to have a very good regard to the subject, and this subject will help you, and ready to receive the subject. Okay, ready to receive the subject. Your readiness is very important. And ගිරා පොතකේ වගේ කටපාඩම් කරලා thermodynamics කරන්න බෑ. You cannot do that. So you have to trigger your brains and minds. Your readiness is very important. So that's all, Putana. So we are learning this in truly good way. And this is the, I would say this is the best thermodynamics class in Sri Lanka. I would say that. Okay, so you are lucky to know this. And only in this class you will be able to learn these things, but those are not in the books. But I will prepare you to receive this knowledge of thermodynamics, including the knowledge in the textbooks. පොතේ තියෙන ඒවායින් මොකුත් දේවල් කරන්න බෑ. You have to experience it, you have to think it. But it is essential to learn the books as well, but we will go beyond the books. Okay, Bhutana, that's all for today. Let me upload this to you right now before leaving the class. Then I would say it is done. So this is file name is thermodynamics and heat transfer applications S2B1 lesson 1. Let me email this right now. Documents S2B1 lesson 1. So thermodynamics S2B1 lesson 1. So recipients UOVT2K19 men, UOVT MEC19. Okay, so good luck to you all, and I believe you will learn this subject very well. Don't worry about the exams. If you know the subject well, you will get good grades. That's all. And I have one thing: if you can have very good innovation idea or innovation concept, or if you can do innovation, in return, I will give you 100% CA marks. That is my commitment. Okay. In return, I will give you 100% CA marks if you can show an innovation related to thermodynamics. Okay, if you can provide something, at least a good concept, right? And even with a patent, so you will get 100% CA marks. So that is my assurance. So of course, other than that, you will receive some assignments, but those who give this innovation output, no matter the marks of the other assignments, you will get 100%. So that is my assurance, and that is what is important. Yeah. Okay, Bhutala, any questions? Okay, let me send this first. So this is the slide. Yeah, I have already emailed to you, so you will receive it. Yeah, I've said it. Did you receive? Did you receive Butala? Come on, now, listen. Like, I hope you have received it. So, any questions before end the? Yeah. Is there same slide? Yes, yes, it's the same. Same slide. Means what we have developed here, I have emailed it to you now. Okay, hambudani to put the slides. Hambudan. Hello.
Okay.
Right. Okay. And my point is, may make a katapadan karan don't memorize this like Girao. You understand something out of this. Okay. That is very important. So this is beyond the books, book knowledge. This knowledge will surely be helpful for the book knowledge as well. And you will be somebody when you realize the book knowledge, the things beyond the book knowledge. And when you analyze the solutions, you have to analyze even based on 4 elements. That is very important. Even vibration and all, when you study vibrations, you can see the 4 elements, the solidity, the flowability, all the things. In every subject, in every technology, you should look into these 4 aspects plus the space. Okay, plus the space. So very good for today. So I expect you to do the designs in the future for all your kitchen appliances and all the thermal solutions. That's all. So let me stop the class now. Okay. So bye
Thank you, sir.
Kutala. Bye Digna. Okay. Good luck to you all. Okay. Good luck. Bye.
Bye.